Our next speaker represents the year 2018. And his current favorite spirit is Rumfire. Please welcome Hadley.
Hey, everyone. So today I wanted to talk about putting R in production. And this is a talk about a topic I don't really know anything about, and I've never done myself. So a lot of this, I'm not going to be showing you any code today. What I'm going to be showing you is kind of my efforts to understand what this thing is all about, with the hope that a few months down the road, it'll start to maybe influence some open source packages or maybe some of Posit's Pro tools. And I also want to say I'm going to be talking about R in lowercase p production, not R in uppercase p production. And I think this is an important distinction to make if you're talking to folks in your IT organization or your DevOps organization, because when they think production, they're often going to think capital P production. And what's the difference? The difference, I think, is basically paging. And that is strange. I am seeing something different to what you are seeing. OK. The difference is paging. So when something's in capital P production, it means it is so vital to the health of your organization, to the correct operation of your organization, that if it stops working, someone is going to tell you, regardless of whether that's 3 p.m. on a Monday afternoon or 3 a.m. on a Sunday morning. That's what capital P production means, that your code is vital to the health of your organization. And so I think you certainly can put R in production, but you probably don't want to, not because there's anything wrong with R, but because you don't want to put data scientists in production. Because your data scientists don't want to be woken up at 3 a.m. on a Sunday morning, right? That's not part of their job description. So it's totally fine to put data scientists in lowercase p production. In fact, really important, because they're still going to be, your data scientists are going to be producing things that are really useful for your organization. They're not so vital that someone has to be woken up if they break, but they're producing dashboards that people are going to be looking at every day, every week. It's really important. And you absolutely can put R into lowercase p production, because the dirty secret of most organizations is they already have Excel in production. Like the number of organizations where there is some semi-automated Excel spreadsheet that is really, really important to someone in the executive part of the company is pretty high. So with that said, what does it mean to put something in lowercase p production? Well, I'm not 100% sure, but I can tell you what it's not. First of all, something in production isn't run just once. If you have a successful data analysis, it's going to need to be run again and again and again and again. It's also not going to be just run on your computer. It's typically going to need to be deployed somewhere else, like deployed in production. That means it's typically going to be running on a server somewhere, not on your laptop. And then finally, if something's in production, it's no longer of importance to just you. You're not just the only person involved in it. You've got folks upstream, like data engineers. You've got your data scientist colleagues who you need to be able to collaborate with. And you have folks downstream, like the decision makers in your organization, or maybe other developers in your organization who want to be able to use the results of your models through a traditional API. Now today, I'm going to focus on these two. So what are the challenges that arise when your R code is no longer running just once on your computer? And so what I want you to do is to imagine that you're a data scientist who works for an ICM company. And what you want to do is you want to help your business by predicting the sales of ice cream tomorrow, maybe based on the sales of ice cream today, the temperature today, and the forecast for tomorrow. So you collect a bunch of data, you write a bunch of code, you fit some models, and then you come up with a beautiful dashboard. And this is great. You've taken into account important variables like humidity and SEMBSUP and schema, and made in holidays, made something that's really useful for your organization to make better decisions. But now you've got to take that dashboard, and it needs to work like every day. You need to kind of productionalize this so that ideally your code stays the same, you get some new data, and it produces the correct dashboard. And now, of course, going into this, the data is going to change, right? Because obviously the ice cream sales are going to drop in winter. But a big risk is that the schema of the data might change. So imagine, you are probably not out there recording the temperature each day. You're using some API to get weather data. And so far, you've been working with it. You've got the dates in month, day, year format and the temperature. And, your API changes. And it's now going to give you the data in a slightly different format. So I'm going to give you all a quick challenge. What I want you to do is compare the old data on the left to the new data on the right. Can you figure out what's different, what's changed? And how is this likely to impact your analysis? So let's take a minute or two, turn to your neighbor, see if you can figure out what's different and how's it going to impact your analysis. Okay, time's up. Who wants to yell out one difference they spotted? The column names, right? We've changed temperature to temp. So what impact is this likely to have on your analysis? It's probably going to break, right? And it's probably going to break actually in quite a good way because it's going to say, oh, you don't have a variable called temperature anymore. What else has changed? The date format, right? We've gone from American style to ISO 8601, the only true way of recording dates. So what impact do you think this is going to have on your analysis? You might be lucky, right? Maybe when you read this data in, you're just relying on whatever library, whatever package you're using to read this to automatically recognize this as a date. So this is still a date. So it might just work. Or if you've explicitly specified that this is month, day, year, this is going to cause an error. Again, probably quite a clear error. What about the last change? I'm guessing it's probably gone from Fahrenheit to Celsius. And what impact is this going to have on your analysis? Your model's just going to give nonsense results, right? This is the worst case scenario because you're not going to get an error. It's just going to silently start returning garbage. And so I think this sort of change, when I talk to folks who are actually doing data science, this sort of change is, I think, the most painful thing that people face today. So how can we de-risk that? Well, the first piece of advice, probably no one is really going to appreciate, but my first piece of advice is you need to make friends. You need to make friends with the people who are producing your data so that they at least know you're relying on it and give you a heads up when something changes. There's a really big kind of people component to this, that you have to be talking to those people, you have to be collaborating with them, and if you're not, technology can certainly, prevent the worst of foot guns, but it's not the real solution. It's going to alert you to a problem, but it's not going to help you solve it. Technologically, what you can do is use a package like Point Blank or Great Expectations to define the schema that you expect for your data. How many of you used point blank before? Okay. How many have used Great Expectations? Okay, a few of these. Really useful tools because they allow you to make precise exactly what you expect the data to look like. And then if the data changes, you're going to get an error. Like, this doesn't solve the problem, right? But it ensures that your analysis isn't just going to give silently nonsense results. You're still going to have to make friends with whoever changed the data and figure out what happened. But at least you know there's a problem. Okay, so what else can go wrong? Well, maybe a dependency changes. It's really like a... You're not updating? Okay, now it's updated. Okay. Having like a somewhere variable lag in 5 seconds and 30 seconds. It's really fun. So a dependency might change. So, you have a new version of your favorite package comes out with amazing new features, but it breaks your code in some way, which is like really frustrating, right? So how do you de-risk this? I think there's some pretty good tools available. I think this is basically a solved problem for reasons I'll talk about shortly. But the way you solve this problem is by using a virtual environment. And what a virtual environment does is just captures for this project what are the versions of R packages or Python packages that you're using. So no longer are you using the latest version of everything or whatever collection of packages happens to be installed on your computer at this time. You're using a specific known set of packages. And you need to do this anyway when we get into this just on my computer problem, because if you're going to run this code somewhere else, you also need to capture those dependencies and ship them somewhere else. And so the reason I think this is basically a solved problem is that if you use POSIT Connect, that when you deploy something to POSIT Connect, it automatically creates a virtual environment for you. It automatically captures, even if you're not already using one, it's going to capture what are the exact version of all of your dependencies, and then every time your report is rerun on Connect, it's going to use exactly the same version of those dependencies. And that seems to have, by and large, fixed this problem for most people. This is not what's causing pain for most data scientists. Now, there's kind of another related problem, and it's not just the dependencies, like the R and Python packages you're using, but it's that entire stack of all the computations that eventually lead up to some electrons moving around on a chip. So like maybe Apple has come out with an amazing new laptop with a new chip on it. Maybe that's going to cause some of your results to change. Or maybe there is just a new version of the operating system. And something about the way that it does, it optimizes matrix algebra means that you get some slightly different numbers. Or something in your other dependency stack, one of your system library changes, or maybe R or Python versions change themselves. So this, I think, can occasionally be a problem. It's pretty rare these days because we have a good solution for this, which is like running containers on commodity hardware. So a virtual environment is going to capture your R and Python package dependencies. A container kind of captures everything else, the version of the operating system, the versions of like BLAST, which is powering your linear algebra computations. That captures everything else. So capturing the dependencies, I think that solves like, 95% of these problems. Capturing everything else that a container captures solves like another 4% or 4.9%. And then you've just got a very weird long tail of other problems. But again, mostly a solved problem. A much bigger challenge is that the universe is also going to change. So there might be a big change, right? Maybe your ice cream shop has moved to the new location on the beach. That's obviously going to have profound impacts on how many ice creams people are buying. But even when there isn't a profound change, like every model is necessarily a simplification of the universe. It's kind of a Taylor series approximation. And as you move further and further away from that approximation point in time, that approximation is probably going to get worse and worse. Maybe not by a huge amount, but it's going to slowly get poorer and poorer. So you might have heard terms like concept drift or model drift or data drift. I think these are all ideas that are reflecting that the universe is changing. It doesn't matter how good your model is today if you're not regularly refitting it with new training data, and then occasionally even thinking about kind of the whole functional form of the model, thinking about rebuilding the model from scratch. It's just going to gradually drift into irrelevance. So how do you de-risk this? I think the way you de-risk this is by you have to acknowledge it. A model is not a set and forget type thing. You're going to have to monitor it over time. You're going to have to regularly, as well as like the dashboard that maybe uses the predictions from the model to show to the decision makers in your organization. You also need a dashboard for you to look at as a data scientist that tells you information about the model metrics. So there's tons of tools for this. Like I know about 2 of them because they're produced by my colleagues at Posit. The first one is Vetiver, a toolkit for R and Python that makes it really easy to create this model monitoring system, this regularly updated reports about the quality of your model. How many people have heard of Vetiver before? Okay, cool. And another really interesting package is called Applicable. How many of you have heard of Applicable? For a few of you. So the idea of Applicable is it's going to try and help you detect if the data you're using to make predictions with has drifted a long way from the data that you were used to fit the model. So have you moved from like an area of confidence where you've got tons of data to an area where now you're like extrapolating the model from afar? And I think this is really important. This seems to me like something that you want, like every time you do a prediction, you really want to know, like, do I think this is a good prediction? And you can't, like, a model can't kind of reach outside of itself and say, oh, this is not in the model, right? This is kind of one of the big problems with, LLMs right now, right? They very rarely say, I don't know. They just make something up. That's a characteristic of every model. But you can use tools like Applicable to at least say, well, the data point I'm making a prediction about is a long way from the data that I use to fit this model. And I probably need to be pretty skeptical about that. And I've talked about models here, but the same thing applies like if you're creating a dashboard or a visualization, right? You've created a visualization, you've created a dashboard that presumably you're going to show the most important things. And those most important things are probably going to change over time. And I think this was something that really surprised me when I sort of learned about how people use dashboards in real life, is that like if a dashboard is successful, it's typically not static. It's going to change over time. And part of this is almost inherent in the nature of a good visualization or a good dashboard, right? If it's successful, people are going to make decisions based on it that were different to what they would have made without it. And so now you've kind of like violated this fundamental like idea that the time after the dashboard is different to the time before the dashboard, right? Because people are making different decisions, and that's probably going to affect how your model sees the world. And the last and kind of most kind of mixed problem is that the requirements change. Like in some ways, like the worst thing that could happen to your dashboard is it becomes so successful that your fat cat CEO is now looking at it every day, and they have a constant stream of comments and feedback and changes that they want made to that dashboard. And I think this is challenging, not just because like you've got to make changes, but I think that's something that like it's not something you learn like as a data scientist in your like college courses. Like how do you respond to like people asking you to make all of these changes? There's some like just the way you think about the problem, the way you respond to people asking you for help, particularly people like above you in the organization. How do you make sure that you can still do your like actual job while responding to the stream of minor changes from people higher up in the org chart to you? But I think there's also like, I don't know, there's something else. I don't really know how you de-risk this. I think one big part of it is this idea of refactoring. That it's really important to spend some time working with your code, not to add new features, not to fix bugs, but to make that code easier to maintain. And that's the true idea of refactoring, is to spend time like improving the quality of your code so that it's easier to change in the future. Like, you have to recognize and embrace the fact that everything you do is going to have to change in the future. And ideally, you want your velocity to increase over time as you get a better understanding of the domain, as you become a better programmer. You want to get faster at making these changes. You don't want to get slower as this kind of like massive like backlog of things start to drag you down. And every time you go back to an old project, like, you just feel awful because you don't really understand how it works, and you're worried about making any change you make is going to make the problem that much worse. And I think like software engineers sort of learn more, or at least software engineering managers understand a bit more how important this is, making changes for the sake of future change. But I don't think that's necessarily something like data scientists and data science managers like know how to talk about and to justify. So these are the kind of the 5 things that I think are the biggest challenges when you have an analysis that's successful enough that you do it again and again and again and again. The schema changing, I think, from what my conversations with people doing data science out in the world, this is the #1 pain point right now. Dependencies and platform changes, sure, they're kind of annoying, but we've got good technology to mostly make those problems go away. The universe changing, I think most people, like, the way they solve that is by just closing their eyes. And the way that people handle requirements changing is covering their ears. But I think really important. Again, like, I don't really know. I've never put code into production, really. Well, I guess I did have. I'll say the one thing that was closest to production is that there was an artist that I really liked who was like on TikTok. So anytime he posted anything on his website, it would go out, it would be sold in like 15 minutes. So what I did is I wrote an R script that ran every 15 minutes on GitHub Actions. It scraped his website and then was supposed to text me when anything changed so I could quickly go and buy it. And I never managed to get that to successfully work. Like, it did actually scrape and collect some data, but I could never actually get it to send me information to make a decision. But because I was like checking on it so often, I noticed that when the site updated, I managed to buy some art. So again, I'm no expert in this, so I'd love you to just take a minute or two, talk it over with your neighbor. Like, are there problems that you've faced putting R in production that you don't think I've captured here? So take a minute or two, and then you can yell out a few things, or you can email me, or LinkedIn me, I guess. So take a minute, talk it over. What have I missed? Okay, time's up. Anyone want to yell out any ideas? Mark?
So one thing that I think you need to address here is also the code itself, right, which you're not explicitly talking about.
Yep.
I actually gave a talk about this at PCR last
We're actually going to cover most of those points in the next part of the talk. So, cool, thanks. Anything else? Yep.
One solution to the schema problem we discussed is contracts. Often follows up upstream schema changes breaking your code because you're using a system a way that the team using didn't handle, like connecting directly to their database and asking them to build an API instead then that team is expected to hold to is one way to approach it.
So do you think of contracts as more of a people thing or a technology thing? Or a mix?
Agreement among people for how technology is used. So it is,
Yeah. Cool. Anything else? Yep.
Your team changes. Somebody leaves and has some institutional knowledge of this project.
Yeah, that's a really good one. That's sort of covered in the it's not just one person doing anymore, which I'm not going to talk about, but I can. Maybe if you remind me at the end and we have time, I'll show you one picture I have made. That I have made, not AI. So those are kind of the problems related to running your code repeatedly. Now I want to talk about the problems more related to running your code somewhere else. And these problems aren't, they're not independent, but I think this sort of breakdown is still useful. Because I think there are sort of three possible ways your code might be running. And not every organization has all three of these, but I think in many organizations do. Like you might be running code on your laptop, right? This is just kind of like the wild west of data science, and depending on your organization, you might be able to do whatever the hell you want on your laptop. You might also have some kind of central compute service. So maybe that's some instance that's running on shared hardware that's fast, or on some kind of container setup that's all centrally managed, so everyone's using the same versions of things. And then you're often going to have, or hopefully you have, some kind of like combination of staging and deployment environment. So these tend to be like run unattended. And you really want two of these things. They're basically identical, but I think the main difference is like your staging environment, like data scientists look at that, and decision makers look at the deployment environment. They're otherwise identical, but it means you can like send something to staging and look at it to see if it's working or not without accidentally breaking the things that the people in your organization use to make decisions. And I think I've kind of put pretty thick lines here because there's some fairly big challenges in each of these transitions. Kind of one of the things that I think like one of the goals of Posit, the company that I work for, is to help with each of these. And when the slide updates, this kind of correspond to our like different products. Like the idea of Posit Workbench, that helps you run something like run the RStudio IDE, Jupyter Notebooks, Visual Code, like in a standardized way that's centrally maintained pretty easily. RStudio Connect allows you to deploy things like apps, Shiny apps, like Markdown documents, Cordo documents, Dash apps, Flask apps, in a way where you can kind of work on your laptop or central compute and just get things published as easily as possible. Okay, now it updated. Okay, and so what I want to talk a little bit about is like how do we cross these various chasms? And I think just the first thing is just to be aware of them, right? At each of these points, there's some pain associated with it. And particularly like if you are a Windows user, like Jared, there's going to be some pain because now when you deploy, when you're using a central compute or deployment, it's almost certainly going to be in Linux. There's also some differences just between desktop machines and servers generally. Then, as Mark pointed out, there's some major pain points moving from an environment where you can debug interactively to an environment where you run a script and 30 minutes later, you get an error message back. And there's also some similar challenges that arise related to like who is doing the analysis. Like typically, on your laptop or in central compute, like the person doing the analysis is you. It's your access to the database that chooses what data to come back. When you start moving into a staging environment or deployment environment, you need to think about like whose access is being used to get the data. This is like particularly important when the data is sensitive and like different people in your organization can see different views of the data set. Okay, so the first challenge to overcome is if you're a Windows user on your laptop, there's a bunch of things that are just different on Linux for like historic reasons. None of them are particularly important, but they're all annoying and they will all catch you out. Like Windows uses different line endings, it uses a different character encoding in R, and it uses a different path separator. And all of these are just like little things you will stub your toe on again and again and again and again. And I guess I stub my toe on these things too, because I generally write my code on a Mac, which for these purposes is functionally a Linux. And then when I test my code on Windows machines, I'm like, oh, the path separator's wrong. Oh, there's some weird thing in my test snapshots because the line endings are different. Also differences because your computer is a desktop and the central computer is a server. Like a desktop is set up for like you. It has set up to use your time zone. It's set up to use your language of preference. It has all of the fonts you've installed, and it has graphics devices that lots of people use and a lot of care has been put into. When you move to a server, it's probably defaulting to UTC time zone. So that's sort of basically the same as Greenwich Mean Time. It's probably using a C locale, so it just sorts things in the kind of the ASCII order. It probably doesn't have many fonts installed, and it probably has kind of crappy graphics devices. The first two are going to cause potentially problems for your code. One of the things like we've tried to do in the tidyverse is make sure as much as possible you don't automatically derive those things. For example, there's a really interesting problem that some locales sort the letters of the alphabet differently to other locales. The order of a factor in R by default is alphabetical ordering, and that determines your contrast of a linear model. So it is possible, it's pretty unusual, but it's possible, and it has happened to people, that by running code in a different locale, you get a bunch of different contrasts outputted from your model. Like the model's still the same, but it's confusing for people looking at the outputs. And the last two are just pain points. Like if you're trying to make sure all of your plots look exactly the same using your corporate style guide, your approved fonts, this is just a pain to get right when you can't easily install fonts on your computer. Another big set of challenges. I would love to know, like, are the bits from my computer like being manually like transmitted somewhere? That's why it takes so long. One of the big differences between the way R packages work on Windows and Mac and Linux is that on Windows and Mac, when you install a package like XML2, which uses the libxmlc library, on Windows and Mac, libxml is like bundled inside that package. And you can just use it without having to separately worry about using libxml. Servers, generally, you're going to install a package from source, which means you need to compile it, which means you need to have all these additional bits of software installed on your computer. That's changing a little bit, like we've done a lot of work with Posit Pocket Package Manager and Posit Public Package Manager, Public Posit Package Manager to make this easier. And there's some great tools in the package, which will tell you like all of the system dependencies that you need to install this package and all of its recursive dependencies. But tends to be a bit more painful, and that might be something you need to get a server admin involved with. It's not something you can necessarily do by yourself anymore. On your laptop, you typically just install all of your R packages in one library. Obviously now on a shared server, you're going to have lots of different libraries because not everyone's going to agree on that. Similarly, it's the Wild West on your laptop. You install packages from GitHub, you install them from CRAN, you install them from Bioconductor, you install them from like some random site you found on the internet. Hopefully on your central compute, that's going to be a little bit more locked down. So that was kind of the transition from your laptop to central compute. There's another transition from central compute to deployment. And that is you are no longer in an interactive environment. So when something goes wrong, when you get an error, you can no longer say, oh, give me a traceback, or let me browse into this function and fix it. So debugging something that's failing on some other computer is extremely frustrating. If you develop R packages, like the way you experience this often is that something fails in your automatic checks on GitHub Actions. And it fails in a way that you can't reproduce locally, and now your iteration speed, instead of like typing a few ideas at the console and getting them back in seconds, it's now like a 20-minute or a 30-minute loop, which is bad not just because it's so long, but it's long enough you do something else, and then you forget about the thing you're trying to do, and then you come back to it two hours later, and you've lost all the state you had in your head. So there's definitely some like techniques that are different. Like when you move into when you're in an interactive debugging environment, it's all about like very quickly coming up with hypotheses about what's going wrong, testing them out, and then discarding them. And because you're in that short iteration cycle, you can do that very simply. When you're in a batch scenario, it's more about like brainstorming every possible thing that could be causing this problem, trying to write some code that can identify all of those cases at once, and then deploying that, so that when you get that information back in 20 minutes, you haven't just answered one possible question, you've answered like 10 possible questions. This is a little bit like if you've ever used SAS to fit a linear model. When you fit a model in SAS, it gives you back every single possible output that you could ever imagine doing to a model. And that is basically because when SAS was written, this was in the mainframe days, you would type out your SAS commands on a punch card, fit the model, and then like 2 hours later, you get the results. You don't want to have to like wait another 2 hours to get some summary statistics on that model. And the other kind of technique that starts to get really useful is this idea of logging, just recording like what is happening in your code, where have you got to? So when it goes wrong, you have some sense of like, how did I get to this point? There's some certainly like really cool technologies out there about like with time travel debugging, where it is theoretically possible in some languages to kind of capture a failure on a server and then bring it back to your local computer in a way that you can interactively debug. That seems like a dream, but not something that is easy to port to R, unfortunately. And then the other kind of issue with it where this difference comes up is when you're authenticating against some server. Now, the easiest way and the way that works just about everywhere is to stuff credentials and environment variables. That works locally, that works in your deployment environment, that is all fine and dandy, but it is not really a great way to do auth because a lot of these credentials ideally should be changing over time. They should be rotating, and that means you need to update them. And if you've relied on like that password in like 15 different data science projects, now you're going to have to go through and update all 15 of those. So ideally, you're using something a bit more interactive, something like OAuth, where you're going to do like a little interactive dance to give the server some permission for you to do stuff on its behalf. It's going to give you something back interactively. This kind of all happens behind the scenes for you, all very easy to do interactively. But if you're doing this on a server, you can't do that kind of interactive dance. And that also forces you to think about, well, like, who is doing this? Who is seeing this analysis? And typically, like if you're doing that locally, you are doing the analysis, you're going to pull down the data that you are allowed to see and work with that. If you're deploying something like a Shiny app, it's also possible that it should be using the data that the person viewing the Shiny app is allowed to see. I think the easiest scenario to think about this is like if you're writing an HR app. Like you should only be able to see the data for yourself and people report to you. You shouldn't be able to see random data for people in the organization. And this, of course, like leads to the worst possible debugging scenario, which is bugs that only occur for other people who can see data that you cannot see. And how you debug that, I have no idea, but thoughts and prayers. So today I've kind of talked about 2 of the 3 things that I think make something a production job, that it's not run just once, and that causes these challenges that the schema might change, your dependencies might change, your platform might change, the uniforms might change, or your requirements might change. And you need to think about these problems. Some of them have good solutions, some of them don't have good solutions, but at least I think acknowledging them is the first step. And then the other problem is that you're not just running it on your computer. You've got this transition possibly from Windows to Linux, from desktop to server, from interactive to batch, and you've got a bunch of challenges related to auth. I'll leave you with just like one last picture, which is my sort of speaking to that last bullet point, that last problem, which is not just you, that now you're working with a team of data scientists, and there's kind of this hierarchy of needs that ideally you want to be able to at least find your colleagues' work. Even better, you should be able to run their work. Even better, you should be able to understand their work. And optimally, you should actually be able to edit it if needed, so that if someone does leave your team, you can still go. I suspect many teams are still down here. Some teams are like striving to get higher up that pyramid, but definitely a challenge of how do you share work across people? How do you build standards in your team? Thank you.